All right, folks, let's keep on going. Right now we're going to talk about the nitration of an aromatic ring. All right, and to do this, we start with benzene, and you would have done this in lab had chaos not ensued, and use nitric acid and sulfuric acid. And what we get is nitrobenzene. Fair enough? Easy. So let's work our way through the mechanism here. The first thing we do is we take a look at the structure of nitric acid. And what happens is the nitric acid, and this is a weird sentence to say, but the nitric acid is kind of the victim here. Because the sulfuric acid, when it generates the hydronium, and there's one reason, there's many reasons, but one of the big reasons sulfuric acid is more dangerous than almost any other is it is also a hell of a dehydrating agent. So the OH on the nitric acid deprotonates the hydronium. I want you to think about that sentence for a second, because what we just did was we just used acid to protonate another acid. We wind up here. And now that OH has turned into OH2. Form a new oxygen-nitrogen pi bond. I don't know why I went around Robin Hood's barn to do that. Go to there, and you make this, NO2. This is your electrophile. All right? Sorry, someone's taking a shower. Now, this is our electrophile, so this will be what adds onto the aromatic ring. It's also a gas, and it's also really freaking dangerous, so you always do an EAS reaction at very low temperatures. So, the pi bonds from the aromatic ring attack the nitrogen and break open the carbon-nitrogen pi bond, which puts you here. All right. Now, we just resonate around the ring. Why do I keep making you do this? Repetition is great for memory. So we draw a third resonance structure. And then the base. Here we know the identity of the base. It's probably water from where we deprotonated it on the last page. And we regenerate our aromaticity here. And there you go. Nitrobenzene. All right. Let's look at sulphonation of benzene. To do this, what we have is we take benzene and we react it with fuming sulfuric acid. And the product is this. This is a benzene sulfonic acid. All right? Now, let's keep this going. How do we, first step, generate our electrophile? Sulfuric acid sulfuric acid, H2SO4, like all of the strong acids, is something dissolved in water. So in this case, sulfuric acid is generated using SO3 and water. And there's a limit to how much of that we can put in there. There are solubility limits. Remember, it is a solution. And the max limit under normal circumstances is 18 molar for sulfuric acid. Now that is really concentrated stuff. I'm not going to lie to you at all. It's almost like jelly. But with heat and pressure, we can overload. We can supersaturate the SO3 into the water. And it stays that way until you relieve pressure on it. And then what happens is fuming sulfuric acid barfs out a lot of gaseous SO3 when you take the pressure off of it. It just pushes that out. That's the fuming in fuming sulfuric acid. You can literally see the SO3 fumes coming out of the liquid. So that's our electrophile, the SO3. Let's draw a structure of it before we actually get to a mechanism. There's our sulfur trioxide. Nucleophilic attack. Open up one of the open up one of the sulfur oxygen pi bonds, and we are here. Now, before you ask, no, this cannot bridge. This oxygen with the anion will not attack the carbocation there. But instead, we're going to resonate around the ring. Dr. Weigel, can we not resonate around one of these rings, please? No, sorry. It's good practice for you. So now we are here. All right, base, remove the proton, regenerates the aromaticity, and this is where you are. All right, and now, let me write that a little bit better. And now, with that anion, what happens is this will deprotonate a hydronium, and what you make is benzene sulfonic acid. All right, so there's this one. And it's 9 minutes. Do I have time for one more? Now, there is one weird thing that can happen with benzene sulfonic acid. Remember, without digging our way through the mechanism again, you can go from benzene to benzene sulfonic acid using concentrated H2SO4. Using concentrated H2SO4. But you can go from the sulfonic acid back to the benzene using dilute H2SO4. And the reaction will just proceed backwards. It's just reverse the mechanism, and that's it. All right, ladies and gentlemen, so I'm going to call it a day on this video. I may or may not get another one put up today, but if I don't, everyone have a good time, stay healthy, and I'll talk to you soon.